Welcome to Physical Science Grade 11 lesson. My name is Thabang Mongatani. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Grade 11s, I'd like to welcome you to this lesson. Today we'll be we're still continuing with the topic electric circuit, but today we'll be looking at internal resistance. Grade 11s, remember, it is very, very encouraged. You are encouraged that before you start with this topic, go back to grade 10. You need to remember what you did in grade 10. We're talking about the pre-knowledge from grade 10. In grade 10, we know that we did the potential. We said you must be able to define the potential difference, and we use the formula V is equals to W over Q to calculate the potential difference. And you must be able to state the unit of for the potential difference, be able to define the EMF, define terminal potential difference, do calculation using the equation V is equals to W Q, define the current strength, calculate the current strength in conductor using the equation current is equals to charge multiplied by time, define 1 coulomb, indicate the direction of conventional current in a circuit diagram using arrows. We're continuing with grade 11 knowledge that you need to know. Explain why a battery in a circuit goes flat by referring to the energy transformation in the battery and the resistors in a circuit. Know that current is the same throughout the resistor in a series circuit. That means grade 11s, if the resistors are connected in series, each and every resistor will have the same current. Describe series circuit as a potential divider. Calculate the total resistance of resistors connected in series. Like the formula that we're going to use is R total is equals to R1 plus R2. And if you have more resistors, you can add R3. Know that the potential difference is the same across resistors connected in parallel. We talked about in series, we call it potential difference divider. And parallel, we call it current divider. Describe the parallel circuit as a current divider because the total current in the circuit is equals to the sum of the branched currents. Calculate the total resistance of a resistor connected in parallel as 1 over Rp is equals to 1 over R1 plus 1 over R2. Solve problem using R is equals to Vi, which means it's supposed to be R is equals to V over I. This one here, grade 11 is supposed to be R is equals to V over I. In grade 11s? Yes. For circuit containing resistors that are connected in series and in parallel. And then remember, grade 11s, we are dealing with a maximum of 4 resistors. Let's look into the exam guideline or in grade 11. In grade 11, under electric circuits, you need to look at what? You must know Ohm's law in words. You must be able to state Ohm's law in words, grade 11, and interpret the data or the graphs on a relationship between current and potential difference and resistance at a constant temperature. State the difference between the ohmic and non-ohmic conductors and give an example of each. You must be able to give the examples of ohmic and non-ohmic conductors, and you must know the difference between ohmic and non-ohmic conductor. Solve problem using R also here. This, it's supposed to be R is equals to V over I grade 11s. And then we say also the circuit will contain resistors that are connected in series, and sometimes you get a circuit that is correct of resistors that are connected in parallel, or you can get series and parallel at the same time. But remember the maximum of resistors, whether both connection are represented in a circuit, you must have maximum of 4 resistors. We continue with the exam guideline for grade 11s. We say solve problem involving current, voltage, and resistance for a circuit containing arrangements of resistors in series and in parallel. In most cases, we mix this connection. It can be series and parallel together, or series only, or parallel only. Explain the term internal resistance. Solve the circuit problem using the formula EMF is equals to current multiplied by external resistance plus current multiplied by internal resistance, or EMF is equals to V load plus V internal resistance. Internal resistance, it means we're looking at internal resistance. Solve problem with internal resistance for a circuit containing arrangements of resistors in series and in parallel. Also, maximum of 4 resistors. Okay, grade 11s. The internal resistance, it's a new topic in grade 11, but it has been there in grade 12. It is very, very important to understand the internal resistance, because this topic, it is very, very important in grade 12. If you understand it now, you're not going to struggle when you come to grade 12. It says here, a battery is said to produce an electromotive force, or EMF. EMF is a potential difference of the battery. If you use a voltmeter to measure the voltage of a battery, it will give you what? EMF. It says now, the definition of EMF is that it is the open circuit terminal potential difference or voltage of a battery. We say it is that the EMF, we say in an open circuit, the terminal potential difference of a battery. It's if you don't switch off, if you don't you open the switch and then you measure the voltage, it tells you that the value that you're gonna get from the value that you're gonna get, it gives you EMF when you're using what? A voltmeter. Are we together, grade 11? That means if you connect a circuit and you leave the switch open, when you use a voltmeter to measure the voltage, that number that you're gonna get, it will be your EMF. Okay, we say suppose we now add a load component with resistance, as shown in the circuit diagram below. We will assume the wire have negligible resistance. That means we don't take consideration of the resistance of the wire. Then the only resistance that we will have, it will be resistance of the resistor R. And in this, because we'll be looking at internal resistance, the battery itself, it will have what? A small resistance. Okay, you'll see as we go forward. This time, we find that the terminal potential difference or the voltage drops from EMF to V load, which is dropping from EMF to the potential difference load, which we call it V load. Since V is less than EMF, it tells us that not all the potential difference or the voltage is being transferred into outside circuit. Are we together? That means inside the battery, while the voltage are still in the battery before it comes to the circuit, not all the voltage will go to the circuit. Some will be lost inside the battery. How so? Because of the internal resistance or the internal resistor. Some is lost due to internal resistance of the battery causing the battery to become hot. Often when you use a cell in a circuit, after a while when you touch the cell, you will feel like it's a little bit hot. That means the internal resistance in the battery has been working, and in that case it causes the battery to increase the temperature. Okay, we continue our grade 11. We say internal resistance refer to the opposition of the flow of current offered by the cell and the battery themselves, resulting in the generation of heat. Are we together, grade 11s? Internal resistance is the one that causes the cell or the battery that will make the battery and the cell to be hot if it be been used for a while. And then we know that if you have a resistant a wire or resistant material, after it has been working for a while, that material will be hot. The same way with battery or a cell. Internal resistance is measured in ohms. The relationship between the internal resistance and the EMF of the cell is given by, we're looking at this formula, grade 11s. This formula, it tells us the relationship of what the EMF, this is what the EMF, and the internal resistance, you'll find it in here where it says this R, small r, is the one that we call what? Internal resistance. While caps R, it talks about the external resistance. Okay, now we continue. This, you can see this symbol here, it tells you that it is what? EMF. And then the terminal voltage, we can represent it by what? By saying V terminal. And then the lost voltage, we represent by V lost. Are we together, grade 11s? Yes. Now we're looking at what? We expand it further. We expand this formula further. We expand this equation further. This we know that it is what? EMF. And this, can you see? IR. It is what? It is IRX. That means, it means what? Our resistance is what? Is external resistance. Where we get what? I is for current in the circuit. Is the current that is flowing throughout the circuit. Now we have R external. R external is the resistance from the external resistors. And then we have IR. IR, it is what? Current multiplied by what? By internal resistance. Okay? Or we can write it like this. This formula, we can write it like this. Can you see? If you don't want to say V terminal, you can say V load. And if you don't want to say V lost, you can say what? V internal. Internal, it comes from where? Internal resistance. Are we together, grade 11s? And then RX, it means what? External resistance. Now we're going further. We're saying we can rearrange the above formula to be like this. How so? We know that we have this formula. We have this formula here. And then from here, we just make I, which is the current, the common factor. Then we take it outside. Then we just say, can you see? And then that means if you take I, which is the current, if you take the current as a common factor, then our formula becomes like this. Are we together, grade 11s? We continue, grade 11s. We said where E, we know that now we're giving the definition of all the symbols that have been used in these slides. And then even their SI units. We say E is an EMF, which means electromotive force. EMF stands for electromotive force. It is measured in volts because it is a voltage. It is a voltage of the battery. Then we have I, which we know it is what? It's a current, and the current is measured in ampere. And the symbol for ampere is what? Is capital letter A. Then we continue. R, we have a capital letter R. In this case is what? Load resistance. And it is measured in ohms. And the symbol for ohm is sigma. It is sigma. Now we have small letter r. Small letter r, it is the internal resistance of the cell, and it is measured in ohms also because it is a resistance. Now we have a V load, or we can say V load or V external. Are we together? Then if we say V load, it is the load voltage that is formed from the load resistance, or the external, the resistance, and it is measured in volts. Then we have V int, which means the internal voltage that is formed from the internal resistance. It is measured also in volts. We say also V load is the potential difference, or a terminal potential difference across the cell when the current I is flowing through the circuit. That means when we talk about V load, we are talking about the potential difference across a cell when current is flowing through the circuit. Okay, grade 11, we continue. We can now treat this as a simple series circuit, and we know that the current will be the same throughout the circuit. Are we together? Yes. We also know the potential difference in series circuit add up to the battery potential difference. That means if you're going to take all the potential difference in a circuit, if you add them together, they will give you what? The EMF, because we said the EMF is what? The voltage of the battery when the battery is not connected to the circuit, or the switch of the circuit is open. Okay. Then that formula, it comes again. Can you see? This one, if you make the current the subject, the common factor, now it's going to give you this formula or this equation. Okay. We say now, okay, this is coming again. Let's keep this. Oh. Okay, we were here. You see, we know that this is EMF, this is the current in the circuit, and this is what? This is the external resistance, and this is the current, this is the internal resistance. Okay? Now, let's look at our first example. Our first example is a multiple choice question. It says, which one of the circuit below can be used to measure the current in a conductor X and the potential difference across its end. That means, in simple terms, we try to saying which one of these 4 circuits are connected well that can give us the right values on the ammeter and on the voltmeter. Which one of these 4 circuits are well connected to give us the correct voltage and the correct current? When we check on, I want to start with A. Is that correct? That is how the circuit is supposed to be connected, where we found the power supply or the cell or the battery, which is connected next to the resistors. You see, look at the ammeter where it's connected. It is what? In series with the battery. Because the reason why we connect it like that is because of what? Ammeters, they are very, very sensitive. Once you don't connect them right, they will be getting bent and they're not going to function anymore. But we're looking in these 4 circuits. Which one do you think it is well connected in order for us to get the correct reading for current and the voltage or the potential difference? When we look into this, all of this, when I check on B, you cannot connect a voltmeter in series. Voltmeter must always connected in parallel to the resistor or parallel to the, not parallel, parallel to the battery. Yes, not in series. And you can see here, from here to here, also we have the ammeter that is connected in parallel. And we said ammeter is very, very sensitive. Once you connect it in parallel, it will get bent. That means the C and B are already out. Let's look at here. You can see here, we have what? Ammeter that is connected in series with the ammeter is connected in series with the potential difference. That means this also is not gonna work. But when you check on A, you can see A is well connected because we have what? Is connected, the ammeter is connected in series to the battery and voltmeter is connected in parallel to our resistance, our resistor. Okay? Oh, this is the same as the first one, grade 11s. We're just gonna jump this one. Okay, now we're coming to this. It said here, the circuit represented below shows the resistance of the variable resistors decreased. How will this decrease affect the reading on the voltmeter and the ammeter? The circuit represented below shows the resistance of the variable resistors. This is variable resistors. Once you see a resistor with this line, that you must know that this resistor is variable. How variable? You can change the resistance of the resistor to the way you want it, grade 11s. Then we say now, how will this decrease affect the reading on the ammeter and the voltmeter? Which one do you think is correct? That means when the voltmeter reading is unchanged, that means in A they say both are unchanged. The ammeter reading is not going to change and the voltmeter reading is not going to change. B, it says the voltmeter reading will decrease and ammeter reading will increase. C, it says the decrease voltmeter reading and unchanged ammeter reading. D, it says the increase in voltmeter reading and increase in ammeter reading. Okay, what is the correct answer, grade 11s? Correct answer is C. We say correct answer is C because on this, once when you change the resistance, that means one of them, the voltmeter reading will decrease and the ammeter reading will stay the same because current does not change in the circuit. We continue with our example. Now we're getting to long question example. It says, what is the EMF? EMF of a cell is always greater than the potential difference or the V load across the cell. That means, that's why we say E is equals to V load minus V internal. Why? Oh, plus, sorry, it's plus V internal. Then, what does that mean? If this grade 11 will never be bigger than this. Why? Because to get this, to get V load, you must subtract a V internal from the EMF. Are we together? That means this will always be less than the V load will always be less than the EMF. Because of what? In order to get the EMF, you must have a V load plus V internal. Are we together, grade 11s? Yes. Let's look at the example now. The example says the potential difference across the cell when no current flows through the cell. It is what? It is 6 volts. Are we together? They said no current is flowing through the circuit. That means this, no current flows through the circuit. That means this is telling you that the switch is open. The current can only flow when the switch is closed. Are we together, grade 11s? Yes. And that means the battery that is connected into the cell, it gives you how much? 6 volts. Okay. Now, when the current is equals to 3.7 ampere is flowing, the terminal potential difference falls to 5.6 volts. And the question is, determine the internal resistance of the cell. You can see here, grade 11s, we're saying our EMF is equals to 6. Then they said when you close the switch, that means this EMF will decrease from 6 volts into what? V load, which is going to be what? 5.6 volts. Can you see that? That means the EMF, the voltage now decreased from 6 volts into 5.6 volts. What causes that? What causes that is what? The internal resistor. Some of the voltage has been lost inside the battery, grade 11s. That means that internal resistance, we want to know how much, what is the internal resistance that causes this loss, this decrease in voltage. Are we together, grade 11s? Yes. And then the formula, because now when we look into our formula, we can see that the first thing we remember, we said when we get any calculation, we must start with what? We must start with a given data. we write down the given data. What are we given, grade 11s? We're given that E is equals to 6 volts and V load is equals to 5.6. And also, what are we given? We're given that because now the switch is closed, the current must flow. And how much current is flowing in the circuit is going to say current is equals to 3.7 ampere. Those are the given data. Those are the given data. Those are the given data. And then because we see here we have EMF, we have V load, and we have current. Then what are we looking for? We are looking for small letter r, the internal resistance. Now, because of that, the formula that we chose is what? Is this one here. And how do you get to this formula? We can get it from where? We can say the EMF is equals to V load plus V internal plus V internal. Then when we expand, we can expand only this and say E is equals to V load plus V internal, remember, is what? I multiplied by small letter r. Then from there, at grade 11, you need to substitute. We know how much is E. We know how much is V load. We know how much is I. Then the only thing that we don't have is small letter r, which is the internal resistance. Then from there, we can say we have what? 6 is equals to 5.6 plus 3.7 small letter r. Then when we make r the subject of the formula, then it will take us to this. And we know that when you use a calculator grade 11, your answer must be 11 ohms. Are we together, grade 11s? Yes. Our final answer is what? 11 ohms. Remember, you must substitute first before you make the subject r the subject of the formula. Are we together? Yes. Okay. Now we're continuing. We are continuing. Another example. We have a nice example in front of us. It says, in the circuit represented below, two 60 ohm resistors connected in parallel are connected in series with a 25 ohm resistor. The battery has an EMF of 12 volts and the internal resistance is what? Is 1.5 ohm. What are we given? Let's write what we're given first. We are given that we have R1, R2 resistor, R1 and is equals to R2, which is equals to what? 60 ohms. Those are this we can call this R1 and this R2. Then this we call it what? R3. R1 and R2, they are equal. They are both equals to 60 ohms. Then another given data is what? We know that small letter r is equals to 1.5 ohm. Are we together? Yes. And then what else are we given? We're given what? EMF. EMF, it's said to be 12 volts. Are we together? Yes, it's said to be 12 volts. Then what else are we given? R3. Our R3 is equals to 25 ohms. R3 is equals to 25 ohms. Then we come to the questions. They said calculate the equivalent resistance of the parallel combination. Parallel combination, they are talking about this one, grade 11s. They are talking about this. We need to find the total resistance of these two for R1 and R2. Remember, we said when we calculate the total resistance of the resistors that are connected in parallel, we're using which formula? We're using this formula. 1 over R total is equals to 1 over R1 plus 1 over R2. Or you can say R total is equals to R1, R2 divided by R1 plus R2. Are we together? You can use this formula or you can use this formula, grade 11s. Now, you must learn how to use both formulas. Okay, now we are asked to calculate what? Number one, they said calculate the equivalent resistance of the parallel combination. Now, number two, it says calculate the total current in the circuit, in the whole circuit. Then number three, it says calculate the potential difference across the parallel resistors. Potential difference across the parallel resistors. Are we together, grade 11s? Yes. Now, I'll ask you, grade 11s, to take snapshot of this because we are moving from one slide to another slide. If you may, or if you can, please take snapshot, use a cell phone to take snapshot of these slides so that when we move from one slide to another, you don't get confused. You know that you have the full information. Okay, grade 11s. Let's go to the solutions. These are our solutions. 1.1, they said calculate what? Calculate the total resistance of the resistors that are connected in parallel. Okay, let's look at this. Here you can see which formula did they use. They use this formula. 1 over Rp is equals to 1 over R1 plus 1 over R2. Then from there, we substituted. We know that R1 is equals to R2. They are both equals to 60 ohms. That is why for R1 we put what? 60. For R2 also we put what? 60. Then when we add them together and manipulate them, then you'll get what? 30 ohms. Okay, let's use another formula. Let's see if another formula can give us the correct answer also. We said another one is what? Rp is equals to R1 plus R2. Okay, sorry. My bad. Is multiply. It must be multiply, not plus. It must be multiply. We multiply R1 and R2, then we say R1 plus R2. Thank you very much. Sorry, grade 11s. Then when we substitute, you're going to say 60 multiplied by 60 divided by 60 plus 60. Then at the top, we're going to get what? 3,600 divided by 120. And then that, it gives us what? 30 ohm. Are we together? 30 ohm. Now, that is how you can see this method and this one. These two formulas, they are giving us the same answers. Then let's go a little back. Let's go back to the previous slide. The first thing they ask us to calculate the equivalent resistance. Yes, we found that to be what? 30 ohms. That's what we did, grade 11s. Then number 2, they said, calculate the current in the circuit. Calculate the total current in the circuit. Yes, because we are given this, when we go back to our previous slide, we wrote down all things that we were given. One of the things that we were given, it is what? It is EMF. Now, we can see here we have what? EMF is equals to 12 volts. Now, colleagues, and we're given, we're looking for what? Current is what we are looking for. We're looking for current, then R1 is equals to R2 is equals to 60 ohm, and we have R3 which is equals to 25 ohms. Are we together? Yes. And then from there, because we have everything except this, and then internal resistance, yes. Let's check how much is our internal resistance. Our internal resistance, they said to be what? 1,5. We say R is equals to 1,5. Then from there, because we have this, and we have all the R together, then we are easily to choose what? We can say E is equals to I R plus small letter r. Then from there, we know that this, it stands for what? Is the total, because now the question says calculate the total current in the circuit. That means we have to use what? The total voltage, and we have to use what? The total resistance in the circuit. Now, at this time, we have only the resistance, the total resistance of the parallel combination or parallel connection. Now, when we look into our circuit, grade 11s, we see that R3 is connected in series with the parallel connection. Are we together? The R3 is connected in series with the parallel connection. R1 and R2, they are connected in parallel to each other, but R3 is connected in series with the two R's, R1 and R2. Now we know that because this combination here, when we calculated it, it gives us what? 30 ohms, isn't it? Now, because we know that when we calculate the resistance or the equivalent resistance of the resistors that are connected in series, we need to add them. Are we together? We need to add them. Then from here, we can say this is R total 1, and then we're going to add it to what? When we add it to R3, then we're going to get what? We're going to say R total is equals to R for parallel combination plus R for R3, which is going to give us what? 30 plus 25. Then we have what? 55 ohms. Are we together? That gives us, this is telling us that the total resistance in the circuit is equals to 55 ohms. The total resistance of the whole circuit is giving us 55 ohms. Then this is the resistance, is the total resistance in the circuit. That is why here we're going to put what? We're going to put 12 equals to I, because our current, it is unknown. Then we continue by saying it's equals to what? 55 plus what is internal resistance? Internal resistance is equals to 1,5. Then we say now, you can see this is exactly as it was there. And then if you're going to manipulate this, then you're going to say I is equals to 12 divided by what? 56.5, which the answer is going to give you 0.21 ampere. Are we together, grade 11s? Yes, this is how we are getting this answer here. I was just trying to explain it. And then the last question, it says, calculate the potential difference across the parallel resistors. Potential difference across the parallel resistors. That is why we didn't use 55 here, because our parallel connection, resistance on our parallel connection, it is what, 30. That is why is this 30 that we calculated here. That is why we use 30 here. And we know we found our current here. Then because the current in the whole circuit is the same, then now we are able to do what? This is this value that you got here. Then the total voltage is going to be what? The voltage that is passing through the parallel connection will be 6.3 volts. Okay, then we are continuing. The next example, it says to us, we have a circuit here. This circuit, the battery in the circuit diagram below, it has what? 12 volts. That means the EMF is equals to 12 volts. Then an internal resistance is how much? R is equals to 0.5 ohms. And we have what? Resistor R is unknown. We don't know how much is R. We don't know how much is R, grade 11s. Then we continue now. Those are things, and then we can see that we have another resistor. We can call it what? R1, which is equals to 2 ohms. Are we together? And you can see we have a ammeter and the voltmeter. Then it says here, 3.1, what is the meaning of the following statement? EMF of the battery is 12 volts. What do we mean when we say EMF of the battery is 12 volts? Simple, grade 11s, we mean that the battery can produce what? A 12 joule energy per coulomb charge. A battery is producing an energy of 12 joules per coulomb charge. Are we together? Yes. And then now they said the reading on the ammeter is 2 ampere. That means our current, we're given that the current is equals to 2 ampere. Then, as we're given the 2 ampere, when the switch is open, when you open the switch, the reading, it gives us what? Okay, 2 ampere. When the switch is open, calculate the reading on the voltmeter. How much will be the reading on the voltmeter? Then number 3.3, it says calculate the resistance of resistor R. This is what we need to calculate, how much is the resistance here. Then 4, it says, how does the change affect the reading of the voltmeter? Increasing, when we're looking at the switch is closed. Firstly, we are closing the switch. Then after we close the switch, then how will that affect the voltmeter? Is the voltmeter reading going to increase or decrease or remain the same? And then they want you to explain, and then they give you how much? 4 marks. That means by choosing one of that is 1 mark. By choosing increase or decrease or remaining the same is 1 mark. Then giving a reason is 3 marks. Are we together, grade 11s? Yes. Now, we have the questions here. The first question, what is the meaning of the following statement? The EMF of the battery is 12 volts. What does that mean when we say the EMF of the battery is 12 volts? There is, you can say, to answer that, you can say the potential difference of a battery in an open circuit is 12 volts. That means you're saying the potential difference of a battery when there's no current flowing is equals to 12 volts. Or you can say the battery does 12 joule of work per coulomb charge. The battery does the 12 joule of work per coulomb charge. That means the battery transfer electrical energy, 12 joule of electrical energy per coulomb charge. Okay, then we go back. Let's go back. And please, grade 11s, take a snapshot of this because you see we are interchanging the slides. Number 2, it says, calculate the reading on the voltmeter. Calculate the reading on the voltmeter. Okay, we are given this, that EMF is equals to 12 volts. And then what else are we given? We are given that R is equals to 0.5 ohm, isn't it? Yes. And then R1 is equals to 2. R1 is equals to 2 ohm. And then we have what? Current is equals to 2 ampere. Those are our given data. Then in order to be asked to be able to answer this question, they calculate the reading on the voltmeter. That means that question, grade 11s, it simply means calculate the voltage on the voltmeter. Okay, now we have 2 options. This is the first option. We can say what? We can go straight and saying V loss is equals to IR. Where does this formula comes from? Where does this formula comes from? This formula, grade 11s, it comes from this formula, V is equals to IR. Remember last week when we were doing Ohm's law, we have seen this formula. Now you can see V is voltage, here V is voltage, I is for current, here is also current, R is for resistance, then here is still what? Resistance. But here, resistance that we're talking about is the internal resistance. Are we together, grade 11s? Yes. Now, by doing that, we say what? We know how much is current, and we know that current is how much is 2. Then we're going to just say 2 multiplied by 0.5, which is going to give you what? 1 volt. 1 volt. Are we together? Then we take that 1 volt. Then we're going to use this formula. Are we saying E is equals to V lost plus V load, sorry. V load plus V lost. V load plus V lost. Nah, this is lost. Then we say now, remember, what are we calculating? We're supposed to calculate this, V load. They want to know how much is V load. We know our EMF is 12, then it's equals to V load plus V lost. This is our V lost that we just calculated. Then V lost is equals to 1. Then when we take 1 to this side, remember, when you transpose from this side to the other side, then you're going to get what? V load to be 12 minus 1, which is going to give us what? 11. Are we together? That means our V load is equals to 11 volts. Is equals to 11 volts. Or you can do it simultaneously like this. You don't have to do steps. You can do it like this. We're saying what? Yes, the formula, we know the formula. Then we substitute 12 for EMF. then this 2, remember here, is what? Okay, let me just do this. From here, you can say E is equals to is equals to V load plus IR. Are we together? Then we know this is 12 equals to V load plus I is 2, R is 0.5. Then that we know that is equals to what? 2 multiplied by 0.5 is equals to 1. Then from there, you just say V load is equals to 12 minus 1 is going to give you 11 volts. Are we together? Yes. And number 3, they say to you, calculate the resistance of the resistor R. Calculate the resistance of the resistor R. How do we do that? This is what we are doing. We have what? V total. We're going to say V. Remember, we need to calculate the resistance of the whole first, of the whole circuit first, and then we minus R from the whole resistance, the total resistance of the circuit. Then what we do is what? In order for us to be able to calculate V total, we need to calculate what? We need to have what? Total potential difference, which is going to be equals to total current multiply by what? Total resistance. Then we know that V total is 12. Why 12? Because that is what the battery can offer the circuit. Are we together? That is what the battery can offer to the circuit. Now we're saying equals to, we know our current is 2. Current in the circuit is what? Is 2. Then we have what? TR. Then now we just divide by 2 both sides. Then total resistance will be equals to 6 ohm. Are we together? Yes. Now we have 6 ohm. But inside this total resistance, we have a smaller resistor or resistor inside the battery. And we know that that smaller resistor is how much? Is 0.5. In order for us to get the total, we said total resistor is equals to the resistance external, R external plus R internal. Can you see? External is the resistor that are on the circuit, and then R internal is the internal resistance inside the battery. Now we're saying we have what? R external, we just calculated it is how much? Is 6, then plus what? Plus, no, sorry. We're looking for this. We're looking for this. Then this is 6 is equals to R external plus 0.5. Then from there, we're going to say R external is equals to 6 minus 0.5, which gives us what? 5.5 ohm. That means the resistor R that we see here, this resistor R here that we see is going to be how much? It's going to be 5.5 ohms. Okay? Yes. Now, we continue. Okay, number 4. The answer to number 4. Let's look at number 4. It says, how does the change? Now, the statement starts by saying, the switch S is now closed. This switch now is now closed. When we close this switch, that means there must be changes that are taking place in there. And then they said, will the change make the voltage to increase or to decrease or to remain the same? And give your explanation. Then we said now, because when you start to close the switch, that means you are decreasing what? You are decreasing the resistance. You are decreasing the resistance and current is increasing. When you decrease the resistance, that means current will increase and loss volts also will increase. Are we together? Loss volts will also increase. And the EMF, doesn't change. The EMF has to stay the same. Then the external potential difference will do what? Will decrease. Are we together? Then the answer that we're gonna choose there is what? Decrease. Why is it the potential difference decreasing? Is because of what? The resistance will decrease. Current will increase. The V lost will do what? Will increase. That makes the potential difference to decrease. Are we together, grade 11s? Yes, because the EMF, it doesn't change. EMF does not change. Okay, we are continuing. We're looking at the activity now. I like this because we need also to look into our graphs, the questions or graph related problems. Here we have, you can see from the circuit, we have 3 bulbs. 2 of the bulbs that are connected in series, and 1 bulb is connected in parallel to these 2. Okay, let's name the resistors now so that we don't get confused. This is R1, this is R2, this is R3. Then we say R2 and R3, they are connected in what? In series. R1 is connected in parallel to R2 and 3. Are we together, grade 11s? R2 and 3 are connected in series. R1 is connected in parallel to R2 and R3. Are we together? Yes. Now, let's go to our statement. It says the bulb with resistance of 2.4 ohms, which is controlled by switch 1. This is the switch 1 that we're talking about here. Is switch 1 here? Is connected in the 2 identical bulbs of unknown resistors. R1 is given to be 2.4 ohms. We don't know R2, how much is the resistance of R2 and R3. What we know is R2 and R3, they are identical. They are identical. That means when you say R1 is R2 is equals to R3, which we don't know how much each resistance is. Okay? Now we're saying this R1 and R2, they are connected next to what? Switch 2. Switch 2. Now it says the graph alongside shows the potential difference across the terminals of the battery before and after the switch is closed. That means before we close switch 1, this is the potential difference. Can you see? It's 12 volts. Then after we closed switch 1, then this is our potential difference. It is 9.6 volts. Can you see? Yes. Can you see now? Yes. Now, let's go on. Can you please, grade 11s, take a snapshot of this slide so that as we go along, you don't get confused or lost. Okay? Then, let's look at the questions. Question number 1, it says, use the graph to determine the EMF of the battery. That is question number 1. Question number 2, it says, with only switch 1 closed, calculate the following. We're only closing switch 1, we're leaving open switch 2. Are we together? We're closing only switch 1, we're leaving open switch 2. Then the question, it says, calculate the current through the 2.4 ohm bulb. That one bulb that is alone, we need to know the current that is flowing through it. Yes, there is a current flowing because now the switch is closed. But if the switch was, when we start, the switch 1 and 2, they were both open. That means the current was not flowing because we have what? Broken circuit. Are we together? Yes. Now, 2, it says, calculate the internal resistor or the internal resistance of the battery. Calculate the internal resistance of the battery. Then, now, the continued says, both switch 1 and switch 2 are now closed. The battery delivers a current of 6 ampere during this period. When we close both switches, then now the circuit, in the circuit there is the current of 6 ampere that is flowing through the circuit. Then the question says, calculate the resistance of each bulb. Calculate the resistance of each identical bulbs. That means we'll be calculating the resistance of R2 and R3. Are we together? Remember, R2 and R3, they are identical. That means their value is equal. Their resistance will be equal. Then question 4, it says, how will the reading on the voltmeter be affected if supposed to be the bulb bends out? How will the reading of the voltmeter affected if the bulb bends? The headlight, that means the bulb 1, sorry, the first bulb, bulb 1 bends out. Or the lamp 1, first lamp bends out. Which one are we talking about? They're talking about this. Let's go back to the resistors. That means this one, the R1. If R1 bends out, when R1 bends out, that means there is no current that's going to flow through it because it is what? It has bent out. Then we want to know how will that affect how will affect the voltage in the circuit. Will be increasing or decreasing, or will be remaining the same? And it says, give an explanation. Give an explanation to your answer. Okay, let's go now. Let's look into the solution. The first question, it says, use the graph to determine the EMF of the battery. Remember, the EMF is the voltage that comes from the battery straight. That means, remember when we start with all the switches open, we had what? 12 volts. That is the maximum voltage that the battery can give. That means when you say determine the EMF, that means we want the maximum voltage that the battery can give to the circuit. The maximum or the voltage inside the battery. Then we'll find out now it is what? Because from here we have what is 12 volts. Are we together? Yes. The battery, it can give us what? The maximum of 12 volts. Then number 2, they said, with only switch 1 closed, calculate the current through the 2.4 bulb, which is, they want what? R1. The question means that they want what? R1, the resistance of R1 resistor. Ne? Then this is how we get it. This is how we get it. Ne? We can use what? We know that this formula is equals to I is equals to V over R. Because of what? We know that the EMF is equals to how much? EMF is 12 volts. And then we're given that the resistance is equals to 2.4 ohms. Ne? And now we're looking for I, which is the current. Then this formula is easy for us. Then we can just say 12 divided by what? No. Okay. We have what? V. Oh, let's go back. Let's go back. This is the maximum that we can get from the battery. But this is after the switch close. This is the voltage that we get. Can you see? Yes, this is the voltage that we get after the switch has been closed. Then here we have what? V, which is going to be what? 9.6 volts. That is why here we're going to use what? We say I is equals to 9.6 divided by what? Divided by 2 over 2,4, which is going to give us what? 4 ampere. Are we together, grade 11s? Yes, it's going to give us 4 ampere. Or we can use this simple equation that we know, because we have a EMF, we have a V load. V load is equals to 9.6, and we have a R. Ne? But we don't have, oh, we're looking for what? No, it's fine. It's fine. Then we continue, because we have that, and then we do have a R. How much is our R? We don't have our R. Then we're going to say now, how do you calculate this? We're saying EMF is equals to IR plus cap small. Then we know EMF is equals to 12 equals to this. Remember, we need for what? We need to calculate the small one. We need to calculate the current. Then this one here, how do we get this? This is how we get it. We know how much is this. We know how much is this. Then we can get this one. We know that this E is equals to V lost, load, plus V lost. Then in this one, we know that is 12 equals to 9.6, then plus V lost. Then when we take this one, this side, we're going to say 12 minus 9.6 is equals to V lost. Then V lost is equals to, is going to give us 12 minus 9 is going to give us 2,4 volts. Can you see? Yes. Then now we got this. We have this. And then we know how much is this. And we know how much is this. Then now we can say from this formula, E is equals to IR plus V lost. Then we say 12 equals to I. We remember the resistance is how much? Is 2.4. 2.4 plus 2.4. Why 2.4 is V lost that we calculated here. Then from here, we transpose this one to there. Then we're going to get what? 12 divided by 12 equals to, 12 divided by 2.4, sorry, divided by 2.4 is equals to 2.4 I. Therefore, I is equals to is equals to what? Is equals to this is gonna give us what? I is gonna give us 4 ampere. When you work out this, it must give you 4 ampere. Okay, any question? Okay, now let's go back a little bit. Oh, here. Number 3, they said calculate the resistance. Are we there? Yes. Calculate the resistance of each identical bulb. Calculate the resistance of each identical bulb. Ne. Let's go. The resistance of identical bulbs. Okay, here we are. We know that if we choose this formula, let's look at this formula. E is equals to I R plus R. Ne. And then yes, we are fine. We are fine. What was given here? We know that is 12, which is equals to what? 6. I is 6. Why 6? Okay, let me see. Let me go back. From here, we found that I is 4. Our I is equals to 4 ohms. Then 2.2. We jumped questions. Let me see 2.2. Internal resistor. Calculate the internal resistor. Yes. Calculate the internal resistor. How to calculate the internal resistors? We need to calculate the internal resistors. Then internal resistors, how do you get it? Is equals to V lost plus I R, isn't it? Then we know that is 12, which is equals to is 12. E is equals to 12. V lost, we said, is equals to 9.6. Then plus I, which is 2. How much is I? We calculate I to be 4, sorry. R. Then when you take this side, it's going to be 12 divided by, is 12 minus 9.6 is equals to 4R. Then making R the subject of the formula, this here okay, it doesn't want me to write again. Let me just do it in here. We're gonna say 12 wow. It doesn't mean want to write, but let's go back so that we can see how it was done. Okay, we see here, from here, we have EMF is equals to IR plus I caps R, current multiplied by external resistance, plus I small internal resistance, current multiplied by internal resistance. Then EMF, it is given that it is 12 ohms, and then we say the loss volts is how much? Is 9.6. We get these two values from the graph. Then we know that we calculated our current to be 4 ohm. This is the 4 ohm that we're looking at. We are talking about. This is the 4 ampere, 4 ampere that we calculated. We're going to put it here. Then now what our unknown will be only the internal resistance. Then when you manipulate this, you say, are you going to say 12 minus 9.6, which is going to give you 2.4. Then it's going to be, we say 4R is equals to 2.4. Then you divide by what? By 4 in both sides. Then what you're going to get is what? You're going to get what? 0.4. 0.6, because when you say 2.4 divided by 4, it gives you what? It gives you 0.6. That means our internal resistance is equals to what? 0.6 ohms. Are we together, grade 11s? Yes. Now, the question, another question that we'll be looking at is what? They say now, both switches, switch 1 and switch 2 are now closed. The battery divide us a current of, okay, the battery delivers a current of 6 ampere. Then from there, from 6 ampere, then would they say calculate the resistance of each bulb. We need to know how much are these bulbs. These bulbs that are connected in series to each other, we want to know how much, what is the resistance of each bulb. Then we're going to look at that. We're going to say now, this is the how we calculate it. Firstly, we need to calculate what? We need to get the total resistance of the circuit. How total resistance of the circuit. Then after we got the total resistance of the circuit, how do we get that? We're going to look at what? We're going to use this formula because we already know the total voltage, which is the EMF, and we already know the total current. It is given to us to be 6 ampere. Let's look, let's check. This is 6 ampere that we're talking about. This is what the current is given to us is 6 ampere. And then also we know how much, we know the internal resistance to be 0.6 because we just calculated it. We just calculated it here. Can you see? Calculate it here. And it is nice if you take a snapshot so that you don't get confused. Now we're continuing because now we have everything else. The 12 is given, is there. We got it from the graph. And then 6 ampere is given to us. R, we need this R that we see here is the total resistance of the external circuits. Total resistance of the external resistance circuit. Then with this one, 0.6 is the resistance of the internal resistor. Is 0.6 is the internal resistance. Okay. Now, when you manipulate this, you're going to start by saying, you divide by 12 by 6, because you're going to divide both sides by 6. Then 12 divided by 6 is what? Is 2. Then 6 is going to cancel 6. Then you're left with what? R plus 0.6. Then because you have 2 on your left, then you're going to say what? Minus 0.6. 2 minus 0.6, it gives you what? 1.4. That means 1.4, it will be our total resistance of the external resistors. Then now, because when we check on our circuit, grade 11th, when we check on our circuit, you can see that this and this, now they're forming what? They are forming parallel connection. They are forming what? Parallel connection. And we know this. This is how much? 2.4. But we don't know R2 and R3. Are we together? We say R1 is connected in parallel to R2 and R3. Okay? Now we continue. We go on. Because now we see that the connection is what? Is parallel. Then we're using this formula here. And remember, you can use another formula that says R is equals to R total is equals to R1 plus R2 divided R1 multiplied by R2 divided by R1 plus R2. You can also use that formula, grade 11th. And in this case, I just want to show you something. In this case, we're taking this R1 and R2 as a component. We're taking R1 and R2, we take them together. We took them as a group. We group them. Are we together? Yes. And in this case, you can see here, you can see from here, we said 1 over R total is equals to 1 over R1 plus 1 over R2. But we know that R total is 1.4, is this one that we just calculated now. Can you see? Then now, because we have 1 over 4, we took it from here. Then you can see R1 is which bulb? Is the bulb, the single bulb, is this bulb here, is R1 on our circuit. We take it as what? R1 from our circuit. Then let's look on the equation. R2, look at R2. R2 is, we take it as R. Why? Because we group both. We didn't say R1 plus R2 because they're connected in series. No, we group them and call them R. We're not going to call them R2 and R3, but we group them to, we say it is what? It is R. Then, after we manipulated this, we found that R is equals to 3.36. R. Remember, in R, we have R2 and R3. Are we together? We have R2 and R3. Then, if R1, if R is equals to R2 plus R3, then we're going to say what? R1 or R2 is equals to 3.36 divided by 2 to get our it doesn't allow me to write. Okay, then here, after we got this SR, then we can say now, oh, I see it, maybe it will write. Oh, okay. Now I'll write with a hand. Now we're saying from here, this R2 that you see here, R2 is equals to R2 plus R3 from the circuit. Are we together? Yes. And then if we have this, then when we substitute here, we're going to say 1 over 1, 4 is equals to 1 over 2.4 plus 1 over R. This R is what? Is this? Is R2 plus R3. Then from here, we're going to do what? We take this side. We're taking this side, then we're going to get what? 1 over 1 comma 4 plus 1 over 2 comma 4 is equals to 1 over R. Are we together? Then when we have here, that means we can say what? We can say, okay, to get our thing together, then you always do what? You can say this multiplied by this. You can say 1 comma 4 how? My calculator is not working. Okay. Then you can say this multiplied by this. Then you know that if you say this multiplied by this, then you know that you can be able to choose what? A lowest common multiple. Then you do it correctly until you get what? R is equals to 3.36. Are we together? And an easier way is to use formula, this formula. Let's use this formula. R is equals to R1 multiplied by R2 is equal over R1 plus R2. Can you see? Then you say what? 1 comma 4 multiplied by 2 comma 4 divided by 1 comma 4 plus 2 comma 4. Can you see? Then at the end, after you've done this, you'll get what? 3.36. Then from there, grade 11s, what we do is, because we say R is equals to R2 plus R3, then what we do is, what we want is, we're going to say now, because this is equals to what? 3.36. Then R2, equals to R3, which is equals to 1,68. How do we do that? How do you get to that? Okay. Now it's working nice. Okay. We say now R is equals to R2 plus R3. We know that R1 and R2 and R3, they are the same again. They are equal. Then this gives us what? 2R. We can say Rx, okay? Then is equals to R. Then we know that this one, then we're going to say what? This is 2 again. In order, then we're going to divide by 2. We're going to divide by 2. Remember, this R is equals to 3,36, then divided by 2. Then when you divide this by 2, it gives you 1,68 ohms. That means R1, R2 is equals to R3, which is equals to 1,68 ohms. Okay? Yes. Let's look quick on activity. Activity number 2. We are running out of time. Let's look quick on activity number 2. It says the circuit below consists of 3 resistors, M, N, and T. A battery with EMF and its internal resistors of 0.9 ohms. The effective resistance between the points A and point B in the circuit is 6 ohm. That means when you add resistor M and N, you must get what? 6 ohm. The resistor of the resistor T is how much? Is 1.5 ohm. When the switch is closed, the high resistance voltmeter V1 across A and B reads 5. Once you close the switch, then V1, it gives you 5 volts. Calculate the current delivered by the battery, number 1. Number 2, calculate the EMF of the battery. Then now they said voltmeter 2 reads 2.5 when the switch is closed. Write down the resistance for N, resistor N. No calculation required to give a reason for the answer. Let's start. We have everything here. We know our given data. We are not given the EMF. We are given the internal resistors. We are given the resistor T to be 1.5. We are given the resistor M to be, is it M? Okay, the total of M and N is 6 ohm. Are we together? Then quickly, let's look at the question. Question 1, it says, calculate the current delivered by the battery. We don't know how much current is that then, but what we know is from here, the formula, this formula, we remember, we look at it last week. I is equals to V over R, and then we're given that our V is 5 ohm when switch is closed. When switch is closed, it says there 5 volts. Can you see 5 volts there? Yes, we're given that the voltmeter 1, this voltmeter here will read what? Will read 5 volts. Okay, then by using that, we're saying RM and RN. Then these two, remember, when they are together, we're given that it is what? It is 6 ohm. That is where we get this 6. This 6 here. This 6 that you see here is what? The resistance of R1 plus R2, because they're even connected in series. Now, when you say 5 divided by 6, it gives you what? 0.83. Nah. Yes, that one is just simply straightforward. Then, let's go back. Number 2, they said, calculate the EMF of the battery. Now, we want to see how much battery is giving us. You can see the formula, we are familiar with the formula. We have the current, we have this R, then we have what? We have an internal resistance. And we have what also? Remember this and this. Ne? This is what we get from this, and this. They give you 6, and this one is given to be 1.5. When you say 6 plus 1.5, it gives you 7.5. That is why when we come to here, we know that 6 plus 1.5, then plus, this is the internal resistance, which is given from where? It is given from us. Here it is, here. Can you see? There, yes. We have, for the resistance, we have 6 and we have 1.5. Then we know that straightforward current, this current that you see here is this one that we just calculated. Then from there we do what? 6 plus 1.5 is 7.5. Then we're going to add that to 0.9. Then we have what? The answer is 6.997. Then when we round off, we get 7 volts. That means our EMF is equals to 7 volts. Then number 3, let's go back to look at number 3. They said now V2 now, it reads 2.5 volts. This V2, what is V2? This resistor. And this voltmeter. This voltmeter, it reads 2.5 volts. And you can see this voltmeter is connected parallel to the voltmeter M. Then, now they're asking a question. They're saying, calculate, give us write down the resistance on resistor N. Ne? Yes. Then this is how we get it. Can you see? This is how we get it. It says here, resistor N is what? Is 3 ohm. How so? How so? This is because of what? We're given that V is equals to 2.5. Isn't it? If V is 2.5, then from here, we've given V as 2.5, and when you calculate everything, we find it to be 6, is giving us 6 ohm. Okay, let's say V, okay, let me go back. We say here, VM, this resistor. There is this resistor here, can you see? This one is 2.5, and then we know we need to calculate this in order to get this one. Now, then if we get this one here, how do we get it? We're going to get it like this, sorry. Because this one, we know this is, the total is 6, isn't it? And then when we find this is 1, is we need to calculate this by using the reading here. And how much is the current that is passing there? The current is 0.85. Then from here, we're going to say what? We're going to say, we want what? R is equals to V over I, where we have 2.5 divided by 0.83. And then that is going to give us what? 3 ohm. Are we together? It's going to give us 3 ohm. Then if this gives us 3 ohm and the total resistance is what? Is equals to 6. Then, and we know the total resistance is what? It must be for Rm plus Rn. And then Rm is equals to 3. Then Rn, it will be what? It's going to be, say, plus Rn 6. Then we take this side, we're going to say 6 minus 3 is equals to Rn, which is 3 ohm. Are we together? Yes. It says here, the resistor in R is equals to 3 ohm. The voltage divider in a series circuit, this is proportional in a series circuit. Since the voltage across M is half the total voltage, it means that the resistance of M and M are equal. Why so? Because when we started with voltage to be 5 volts. And then now they said the voltage has now decreased to be equals to 2,5 volts. That is half of that. Are we together? That means if you halve the potential difference, you are saying now the resistors also must be the resistance must be also halved. The total resistance must be halved. Are we together? And remember, our total resistance, it was what? It was 6. Because we halved the voltage, now we must halve the resistance. That is why we get it to be 3. Are we together? Yes. Okay. Because of time, I'm gonna stop here, and thank you very much. We'll see you next week.